This shows the outline of my presentation. Do you know, have you ever seen this tree before? This tree is called Monkey Pod and is located in Manawap Garden Park in island of Oahu in Hawaii. This is a Hitachi tree used in the many TV commercials in Japan. As symbolized by the Hitachi tree, the Hitachi group is comprised a number of individual businesses, the branches, that combine to form a large tree, which flowers and grow fruit. We draw the collective strengths of these branches to create value or fruit and thus contribute to the society. Let me tell you a little about the Hitachi Group. We generated consolidated revenue of 10 trillion yen annually. We are active in numerous fields, including information telecommunication systems, including power industrial systems, digital media, consumer product, high functional materials component, and others. Our overreaching goal is to create a new value in a wide range of fields, as illustrated here. Hitachi's fundamental credo is to contribute to the society through the development of superior original technology and products. Guided by this credo, we have set three main environmental themes to achieve our environmental goals as pioneering sustainability. These three themes are global warming prevention, ecosystem conservation, and resource recycling. At the corporate level, we unveiled a medium-term plan called Environmental Vision 2015 in March 2006, and a long-term plan called Environmental Vision 2025 in December 2007. Under Environmental Vision 2015, we continue our effort to reduce carbon dioxide emission to achieve emission neutral status. The goal of neutral emission status means we are going to cancel out carbon dioxide emissions generated when producing the product by reducing emission during use and recycling by the same amount. Under the long-term plan, Environmental Vision 2025, we will promote further reduction in production carbon dioxide emissions during use by 100 million tons annually in fiscal year 2025. Incidentally, total emission worldwide today were 20.6 billion tons. Now, let me turn to the initiatives related to ICT operations. We believe that we can help reduce carbon dioxide emission on two broad fronts. One is through the provision of power-saving ICT systems. The other is through the resource reduction by the use of ICT systems. To provide power-saving ICT systems, we are promoting a power conservation plan called Harmonious Green Plan. Under this, we will also reduce data center power consumption. There are a number of examples of how ICT systems can help reduce resource use. A prime example is work style reform we are implementing at Hitachi now. In addition, we have developed an evaluation method called SI-LCA to quantify the reduction of resources. The goal of Harmonious Computing Plan is to reduce carbon dioxide emissions from ICT equipment by 330,000 tons over the next 5 years. To achieve this goal, we have developing and applying power-saving technologies that include the component level and product level and operational level. At the component level, for example, we are employing a power-saving component. At the product level, initiatives include developing efficient cooling method and effectively combining storage unit cooling method for reducing power consumption. At the operational level, we are developing virtualization technologies for optimally controlling power consumption according to the task being performed. These are just some examples of our effort we are making at each level. We have already launched some products incorporating these technologies. These include power-saving, blade server, storage systems, and router switches. Let's move to the power saving in the data center. The goal of Cool Center 50 project is halving power consumption at our data center over 5 years. The Harmonious Green Plan I discussed earlier will lower IT equipment power consumption. However, the data center also uses other equipment like air conditioning and power supply systems. Therefore, reducing consumption by IT equipment alone will not substantially reduce overall power consumption at the data center. So, for this reason, we are developing solutions to lower overall power consumption at data centers. These solutions include airflow and thermal analysis for efficient air conditioning. And all this effort, we would like to reach the 50% reduction of power consumption at the data center. Next is how to utilize ICT to reduce the carbon dioxide emission. One example of our effort to reduce carbon dioxide emission is a work style reform program. This program involved some 50,000 people at Hitachi. We were using thin client PCs which do not have a hard disk drives to bolster information security and allow our employee to work outside the office or at home. Another feature of our program is that employees are free to sit where they like, rather than sitting at the designated desk. This work style increases amount of time our employee can spend with client by up to 30%. Floor space efficiency increases by the same percentage. There are also other benefits. We have reduced the need to move people and things. And electronic filing system cut consumption of paper. All these changes can contribute the carbon to emission reduction, carbon dioxide emission reduction. However, we need a way how to evaluate it. This is why we developed SI-LCA, a new method for assessing systems over their life cycle. SI-LCA evaluated the environmental impact of systems and services throughout their life cycle. When new systems are introduced, they yield positive benefit, such as reduction in the movement of people and things, and lower resource consumption. However, the use of ICT equipment also has negative side, like system manufacturing requires resources. ICT systems requires power. SI-LCA evaluate both positive and negative benefit at the 10 life cycle stages, as you can see here, from design through to the shipment and other so on. This slide shows the result of SI-LCA evaluation. Let's look first at the evaluation result for the entire life cycle. The upper bar shows the carbon dioxide emissions before the new style was adopted. And the lower bar shows the emission after the adoption. You can see that 20% reduction we can achieve. And look at the bottom chart. You can see that 30% reduction we can achieve just the usage stage only. So as illustrated here, so we can evaluate each stage, also a total entire stage, individually. So this system is general purpose program, and application is not limited to the work style reform. The conclusion, the use of ICT systems help prevent global warming, and benefit can be quantified. We developed SI-LCA, the kind of evaluation systems, and we can evaluate our effort as a quantified number. The use of leading-edge ICT systems to support global development should help prevent global warming. Multinational cooperation and evaluation and standardization are necessary for further advances. And I believe that ITU can do a big role to make such kind of standardization. This is end of my presentation. Thank you for your kind attention.